Hi, this is day 26. Am I right? Yeah, day 26. So I have a feeling it's going to be a little long. So hopefully not. I'll try to finish as soon as possible. So the first few questions are dedicated to your last test because there were some mistakes here and there that I'd like to see you correct before, obviously, your state test. So one is the tree diagram. Now, it doesn't matter which order you start with. You can start with the pants. So here, sorry. Tim is deciding on what to wear for dinner, to dinner, or for dinner. Here are his choices. He has a choice of sweater or hoodie, jeans or shorts, and then sneakers, sandals, or boots. So, like I said, was trying to say before, it doesn't matter if you start with the shoes and then go to pants and go to top. Um, it's really up to you. So here's my starting point. So let's start with, I'm just gonna write S for sweater. He can write, he can wear a sweater, and I'll write SW, or he can put a hoodie. Now, for each one, so on here, I have two things happening. On the second one, I'm going to have two things happening as well for each of my two choices. So here I'm going to have two choices, jeans and shorts. Jeans, and I write shorts, SH, and jeans and shorts. And I guess another way to remember is, and then for the last one, you have your last choice here. You have three. So for each of these choices, you're going to have to put three. So change colors here. So for jeans, I can wear sneakers, SN, sandals, SA, or boots. And then for shorts, again, same thing. I'm going to have three choices, sneakers, sandals, and boots. At the bottom, now we're taking care of the hoodie with jeans. So hoodie with jeans, and again, you're going to see three choices, sneakers, sandals, or boots. And if he wears shorts, he's still going to have sneakers, sandals, and boots. You need to list your sample space. So let's start with a sweater. Then he can wear jeans, and he can wear sneakers. He can also wear a sweater with jeans and sandals. Sweater, jeans, and boots. Now we can move on to the next one. It's different color. Sweater, shorts, and sneakers. Sweater, shorts, and sandals. Sweater, shorts, and boots. So that takes care of the top part over here. Pick another color. Let's pick black here. And at the bottom, we're doing this one. You can have a hoodie with jeans and sneakers, hoodie, jeans and sandals, hoodie, jeans, and boots. And lastly, you can wear hoodie, jeans, and sneakers. No. We did the jeans already. So this should be hoodie, shorts, and sneakers, hoodie, shorts, and sandals, hoodie, shorts, and boots. So those are all my choices. And I need this because you're going to need it to answer the following question, the following three questions. So question A says, what's the probability that he will be wearing sneakers as his shoes? So over here, how many of the different, so he had first of all, how many different outfits did he have? Well, he had 3, 6, 9, 12. So there are 12 different outfits total, right? So in how many of them was he wearing sneakers? Well, out of 12, how many was he wearing sneakers? Well, here, 1, 2, 3, 4. 4 out of 12 outfits, he was wearing a sneaker, okay, as his shoes. So 4/12, or if you want to simplify, 1/3. That's the answer for A. What's the probability that he's going to be wearing a hoodie and boots? So we need to look for a combination where it says hoodies and boots. So now all this top part here we can ignore and look at the bottom. So hoodie definitely, and what is it? Hoodie and boots. So H and B. Well, here's an H, here's a B, and here's another H, here's another B. So out of the 12 outfits, how many did he have hoodies and boots? It would be 2 out of 12, or 1 out of 6. So that answers question B. Question C says, What's the probability he's going to be wearing sweater, jeans, and sandals? So we need to look out for sweater. We're looking at the top part here. So sweater, jeans, SW, jeans, and sandals. Oops, here. Sweater, jeans, and sandals. Sweater, jeans, and sandals. Nope, that's the only one. So out of the 12 possible outfits, only one of them was sweater, jeans, and sandals. So he had a 1 in 12 chance of actually wearing that. And this would be how you should have or should do. Moving on to risk replacement. And I wrote a little couple of sentences here, so just remember, risk replacement means that whatever you take, whatever you select goes back in the bag. So if you have a bag full of marbles or cards or whatever it is, you take a look at it and you put it back in the bag. So therefore, the total does not change. You will always have the same amount because you're always putting whatever you take out, you're putting it back in. So the total does not change. And also remember that if the problem is a compound probability, then you have to multiply the probability of the first times the probability of the second, right? So if you're asked what's the probability of getting a blue marble and then a green marble, well, you have to multiply the probability of blue times the probability of green. And on the test, some of you added those two, which didn't really make any sense. Okay, so a bag contains, and let me write this down, 7 blue, 4 pink, and 4 yellow cards. 3 pink. 3 pink, and 4 yellow cards. A card is selected, a card is drawn at random and is replaced. So you're going to take a card out of this bag, look at it, and going to put it back inside. So now we have a total of 7, 10, there's 14 total. There will always be 14 total because we're always returning whatever we take out back in. So what's the probability of selecting a blue and then on the blue card? So probability of getting a blue, probability of getting a blue. Well, probably there's 7 blues, so 7 out of 14. So you take the first one out, look at it, put it back in the bag. Now you're going for the second one. You're going to try to get another blue. How many blues are in there? There's still 7 because you put the first one back, so it's 7 out of 14 again. Multiply it. You can reduce this to 1/2, and this is also 1/2. So the probability of that happening is 1/4 or 25%. Okay. What's the probability of selecting a pink and then a yellow card? Well, the pink will be, there's 3 pinks out of 14. And you look at the pink, you put it back, there's still 14, and you want to select a yellow card, and how many yellows? There's 4. Can you simplify anything? Yeah, we can simplify this guy here, 2 and 7. Now we multiply, it's going to be 6 over, really? No, oops. So it is right, but I want to simplify this again, 1 and 7. So a probability is 3 out of 49 chance that you're going to get a pink and then get a yellow card, which is not that great of a chance. What's the probability of selecting a blue, then a yellow, and then a yellow? Okay, so what's the probability of getting a blue card? Well, like we said before, there's 7 blues out of 14. You take a look at the first card, you put it back. Now in the second try, you want to get a yellow. There are 4 out of 14. Take a look at the card, put it back in the bag, and you're going for your third card. There's still 14 cards in there, and you want to get another yellow, which is 4 out of 14. So you had a 7/14 chance of getting a blue, a 4 out of 14 to get a yellow, and then a 4 out of 14 again to get a yellow. And you just multiplied that out. This is 1/2. This is going to be 2 over 7. It's going to be 2 over 7. And across these two, so it's 2 out of, it looks like 49. My math is not mistaken. You have a 2 out of 49 chance of accomplishing, and I don't even know where I am. Oh, on letter C. Okay, 2 out of 49 of selecting that. Okay. Letter D. What's the probability of selecting a blue marble? Okay, like I said before, we established that there were 14, and the probability of getting a blue marble is just 1. That's it. You had a 7 out of 14 chance, or half. What's the probability of not selecting a pink marble? I want to pick everything but pink. So there's 14 total, and anything that's not pink counts. So the blue counts, and the yellow count. So 7 plus 4 is 11. So there's an 11 out of 14 chance that I'm going to get a card that is not pink. Okay. With replacement means that whatever you select does not go back in the bag. Therefore, the total does change. You will have one less every time you draw or take out something. If you find the probability of 2 or more events, you have to multiply the probability of the events. Do not add them, because that is just too weird. Besides, who told you to add them? And I mean that question. Where are you getting the adding from? So, let's look at this. 6 green, 5 white, 3 orange, which makes our total, I don't know, 11, 14. There's 14 in total again. Okay. So 2 marbles are going to be selected. Once a marble selected, it is not replaced. So once you take something out of the bag, we do not put it back. So our total is going to change. It's going to have 1 less. So what's the probability of getting an orange followed by an orange? So let's find the probability of the first orange. Well, there's 14 total. Probability of getting an orange in my first try is 3 out of 14. So I take an orange out. I put it out. See, here's my orange. I'm going to leave it out here. I'm going to go back in the bag. Do we have 3 oranges still? No. We have 2 oranges left over, right? So on the second try, the probability of getting an orange is going to be 2 because 1 it's outside, right? And are there 14 in the bag right now? No, there's 1 less, which is 13. 2, 1, 7. So the probability is going to be 3 over 91. What's the probability of selecting a green followed by a white? So let me just erase a few things. A green followed by a white. So what's the probability of getting a green? Probably getting green is 6 out of 14. So I take the green, I put it here on the outside. I can cross this because there's no green, 6 green anymore. There's 5. Now I'm going to go back in, and I'm going to take a white. Well, first of all, there's not 14 anymore. There's 13. And then we're going to get white, and the white we have 5 whites. So simplify 3, 7. 15 out of 91 chance of that happening. C. What's the probability of something? Of selecting a white followed by an orange and then a green. Okay, so now there's 3 things happening. First one. What's the probability of selecting a white? Well, in the first try, when there's 14, there are 5 whites. So I take that white and I'll put it out here outside. There's no longer 5 whites, there's 4, there's no longer 14, there's 13 total. Times, right? I adjusted my bag, I adjusted my total. Let me go back second time, and I want to get an orange. How many oranges are there? Well, 3 oranges, the 13 total. So I'm going to put my orange here on the side. I'll go back in the bag, let me readjust things. So there's no longer 3 oranges, there's 2, and there's no longer 13 total, there's 12. And I'm going to take a white one. No, I'm going to take a green one. Right? So how many in total? Well, now there's 12. And how many greens? 6 greens. Same thing. Multiply them around. Let me just simplify what I can. I think that's it. I can't simplify anything else. So that's going to be on top, 5 times 3 times 1 is 15. At the bottom, 14 times 13 times 2 is 364. So chance of that happening is 15 out of 364. Very small chance. And that's it. And then the last one says, what's the probability of taking a green followed by a green and then a white? So let's do that. So first try, there's 14 in my bag. I'm going to get a green. So there's a 6 out of 14 chance of that happening. Let me put the green here on the side. Let me put a multiplication sign. Let me readjust things. There's 5 greens now, and there's 13 in total now. So I'm going to go for my second try, and in my second try, I want to get another green. But there's only 13 there. Do I have 6 greens? No, I had 5, right? Because I put 1 on the side on the first one, so I have a 5 out of 13 chance of that happening. So let me put my second green out here on the side. Let me go back to my bag, readjust. I don't have 5 anymore. I have 4. I don't have 13 in total. I have 12. And on the last try, I want to get a white. Well, it's probability of getting a white. There's 5 whites in the bag. And how many total? 12. Simplify. Is there anything? Yes. 1 and 2. That's it. 25 over, I have no idea what it is. 14 times 13 times 2 times 2 equals 364. So 25 over 364 chance, which is less than 10%. Okay. So hopefully you understand now that we multiply, and you really be careful with the replacement and without replacement. So a die was rolled 100 times and the results were recorded. So again, this is a experimental probability, and here's the results of my experiment. So number 1 came out 16 times, number 2 20 times, number 3 22, number 4 10, number 5 18, and number 6 14 times out of the 100 times I rolled. What's the probability of rolling a 5 or a 6? Well, probability of rolling a 5 or a 6 was 18 plus 14, right? So if I rolled a 5 or if I rolled a 6, I win. So I have to add these two. 18 plus 14 was 32 out of 100. I'm not going to simplify. I'm just going to leave it like that. What's the probability of rolling an odd number? Well, the odd numbers are 1, 3, and 5. And how many times they come up? 16 plus 22 plus 18. That's going to be 40, 56. It was 56 out of 100 times an odd number came out. Which result came closest to match the theoretical probability? Meaning, let's say that before you rolled and you were just looking at a die, which, what's the percentage that you would expect for each one? So if I asked you before rolling a die, what's the probability of landing on 1? It would be 1 out of 6, 2, 1 out of 6, 3 out of 1 out of 6, etc., right? So 1 out of 6, right, for each of these numbers, I was expecting 1 out of 6, but if I roll it 100 times, right, so the probability of each number landing on that number would be 1 out of 6, and if I threw it 100 times, I'd expect each number to come out. I multiplied that, 16.6, so about 16 or 17 times. So each number should have come out 16 or 17 times. Did any number match that? Well, number 1 matched that. And so the winner is 1. So number 1 was the one that actually matched the theoretical, right? When we looked at it, we said that each number should come out 1 out of 6. And if we multiplied that by 100, each number should have come up 16 or 17 times. And the only number that really followed that was number 1. What's the theoretical probability of rolling a number less than 3? So 1, 2, 3, 4, 5, 6. Here's my die. And before you roll it, and you were looking at this, and I asked you, what's the probability of rolling a number less than 3, which means 1 or 2? The probability of landing on 1 or 2 is going to be 2 out of 6, right? Or 1/3. The probability of landing on 1 or 2, theoretically, is 1/3. 1 or 2, right? In my experiment, so this is my theoretical probability, 1/3. In my experiment, what was the probability of landing on 1 or 2? So we landed on 1 6 times and landed on 2 20 times. So that's a total of 36 out of 100. And can we simplify that? 18 over 50, and simplify that again, 9 out of 25. So, and what was the difference between the theoretical? Theoretical was 9 out of 25, and the theoretical was 1/3, and the theoretical was 9 out of 25. So we can subtract them, right, to see the difference. So we can make this into 75, right? 75. This is 27. This is 25. This was 2 out of 75. The difference was 2 out of 75. Okay, between this theoretical and the experimental. Sam is going to roll the die another 80 times. Based on the previous 100 rolls, how many times would you expect it to land on the number 4? Well, it landed on the number 4. So it landed on number 4 10 out of 100 times in the experiment. And we're going to use that to predict how many times the next 80 it's going to land on number 4. So we can definitely simplify things here. And the answer is 8. So out of the next 80 times, we expected it to land on 4, 8 times. What else? Probability of landing on a number greater than 1. So in our experiment, how many times did it land on a greater number on a number greater than 1? Well, greater than 1 would be this one, this one, this one, this one, this one. So that'd be 100 minus 16, which is 84. So in our experiment, 84 out of 100 times it landed on a number greater than 1. So if we multiply that by 80, and cross, I'll just use the old-fashioned calculator. Well, it says 67.2. You can't have 67.2 overall, right? So we're going to round up to 68. So out of the next 80 times, we expect that 68 times it will roll a number greater than 1. Darth Vader's class is selling candy bars to raise money to buy new lightsabers. The first 15 students recorded the amount they raised. If there are 22 students in the class, predict how much money was raised for the new equipment. Well, here's the problem. We only have the data for the first 15 students, right? So student number 15 raised this much, student number 16, 17, 18, 19, 20, 21, 22. How much money did these guys help raise? We don't have that amount, right? So what I can do is going to find the average here. Let's add all that. So 55 plus 45 plus 57 plus 10 plus 59. It's going to plus 60 plus 49 plus 52 plus 53 plus 40 plus 56 plus 63 plus 56 plus 70. Please work. Yes, it did. So the 15 kids here, 15 students, they collected a total of $725. So if I divide this by 15, I know that divide by 15, I know that each kid, so the mean is $48 and I'm going to write 33 cents. So the mean, the average amount was $48.33 for these 15 what do you call it, for these 15 kids. Now, what I can do is use that average. So I can say that each student, literally that's what it means, the mean, right? Each student brings in $48.33. So I'm going to take that, use the mean, and multiply by 22. And I'm going to say that they will bring in a total of $1,063.26. So that's how I would do this problem. Okay, I find the average here, and then I would use the average and multiply it by 22. And that average represents what each kid brings in. Okay, so 6, Mr. Skywalker polled his students to find out how long they studied for the last math test. He then recorded the number of questions answered correctly by each student on the table below, based on those results. So if you studied less than 1 hour, those kids who said they studied less than 1 hour, this is how many answers they got correct. One kid got 25, 18, 14, another kid got 27 correct, 25 correct. So, and then those who studied for more, or 1 hour more, they got 42 questions correct, 35 questions correct, 27 correct, 42 correct, 38 correct, 39 correct, and 24 correct. So they're asking us to do a dot plot for both. Okay, so I'm going to do a dot plot for both. So the smallest one here is 14. And the highest one is 25. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So it's not the best dot plot in the world. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25, there's one kid. 18, 14, 26, 27. 27, there's another kid. 25, there's another kid. 14, another kid. 18, 25, and 23. Wow. Really spread out, right? I'm going to do another one here, hopefully. And the lowest one here is 24, 25, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. So this is my highest one. 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. I'm not going to put all the numbers. 42, one kid. 35, 42, no, 27, 42, 38, 29, and 29 is here. 29 and 24. Ugh, I don't know. What can you conclude from the plot? From the dot plot? Well, second class, the one that studied 1 hour, obviously the range is higher, right? The higher grade, the max is higher, the range is higher. The range here is 42 minus 24, which equals 18. And 27 minus 14 equals 13. So the range is actually higher here. Okay, so, but the max score is higher, okay, than the max score over here. What a difference in there mean? So you just gotta add them up. 25 plus 18 plus 14 plus 25 plus 27 plus, hey Miles, 25 plus 18 plus 14 plus 27 plus 25 plus 14 plus 18 plus 25 plus, what is that last number? 23. Enter. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 9. And the mean is 21. And then bottom one is 42 plus 35 plus 27 plus 42 plus 38 plus 29 plus 24. Enter. And you divide by 1, 2, 3, 4, 5, 6, 7. Divided by 7. And the mean is 33. Okay, so obviously right there the average is much higher average for those who studied, what do you call, studied, so let me put the mean over here. The mean is 21 and I'm putting purple. That's the mean for this class, and the mean for this class is 33, 30, 31, 32, 33. Curious to know who had the higher MAD. Unless I did this really wrong. So, just by looking at it, I think that the higher MAD would be here. They're more spread out. Doesn't mean they're worse. I mean, just means that because they studied more, they were able to get grades that are more to the right? Whereas these guys, they were more. It looks like they're more together. I mean, they're still spread out. They're more together, but on the lower side, right? They weren't able to pass that 27. Well, here I had kids who were in the 27 range, here 27, as well as they were able to surpass that and go all the way out. So to find a MAD, you have to find the differences between 21 and each of these sets. So this one, each of these points, find the difference, right? Remember, it can't be negative, so find the absolute values if you like. So I'll use purple for the top. So it's going to be 25 and 21 is 4, and then 18 and 21 is 3, and then it's 7, and then it's 6, 25 and 21 is 4, 14 and 21 is 7, 18 and 21 is 3 again, 4 and 2. So that's the difference between 25 and 21, and the difference between each of those points and their mean of 21. Let me just write it in purple. So now you have to add them, right, and divide it by 9 again. So we got 4 plus 3 plus 7 plus 6 plus 4 plus 7 plus 3 plus 4 plus 2. You got 40. 1, 2, 3, 4, 5, 6, 7, 9. So that 40 divided by 9. So their MAD is divided by 9, sorry, is 4.4. 44. Now here, the other guys, I'm just keeping in red. So how far is 42 from 33? 35 from 33. So let's find the MAD of those. 42 and 33 is 9, 2, 27, 33, 6, 9 again. Yeah, 9 again. 38 and 33 is 5, 29 and 33 is 4, and 24 and 33 is, no idea, is 9. So 9 plus 2 plus 6 plus 9 plus 5 plus 4 plus 9, enter. We got 44, and we're going to divide this by 1, 2, 3, 4, 5, 6, 7. And the 44 divided by 7 should be 6.28. And yeah, I was sort of right telling you that these guys would have the higher MAD. Okay, so higher MAD because they're a little bit away, they're further out from the mean. Okay, it just means that they were able to really get higher scores, right? That should be, and then two more questions. So again, quick review on what do you call box plots. That's the min value, maximum value, Q1, the median, Q2, if you want to call it Q2, that's fine, and Q3. And remember, each of these parts is 25% of data. The box here represents 50%, or 25 here, and 25 here. Okay, and that's it. You need all those 5 points to create a box plot. Now here I'm going to ask you to, first period class, what is the min? The min looks like it's 60. The max looks like it was, is that on top? I'm going to write 96. Sort of, yeah, let's write 90, all right, 97. Q1 is 75. The medium is 80. The Q3 here looks like 90. The IQR, which is Q3 minus Q1, Q3 is 90, Q1 was 75, so 90 minus 75 is 15, and the range, which is the lowest, min minus the max, 97 minus 60 is 37. Second period class, the min was 70, the max was 95, Q1, which is 80, Q2, which is 85, Q3, which is a little bit higher than 90, 92, and and that's it. The interquartile range is like Q3 minus Q1, so this looks like 12, 92 minus 80, which is 12, and the range, the max minus the min, is 25. So period 1 class had the higher range, right? They had, I guess, kids, you can obviously tell that their MAD would be a little bit bigger, and because they're more spread out, right? Which class did better on the test? Obviously, well, I guess not obviously, but you had, well, 50% of the first period kids got between 75 and 90. 50% of the second period kids got between 80 and 92. Okay, so we have the IQR is definitely, what do you call it? 50% is more here, right, on second period class. So we had a bigger percentage with that grade between 85 and 90. I'd say period 2 class, right? Their range was a lot less. Okay. Their maximum score might not have been as great as period one, but we don't know how many people got that high score in the first period class. Okay, we definitely have more people from 80 and higher in the second period class. Okay, there's a bigger number of people. 50% of the students in period one are from 80 less, as opposed to only 25% of the group here score from 80 and lower. And in period two class, nobody failed. So there's all that to take account. Okay, well, hopefully that reviewed a little bit for you guys.